lagi ya.
Pernah.
To the countdown.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hai. Salam sejahtera guru-guru dan pelajar-pelajar sekalian. Selamat datang ke Pusat Tuisyen Akademi YouTuber. Usaha sama e-didik Malaysia dan Kelab Guru Malaysia. Pusat Tuisyen Percuma ini adalah yang pertama di Malaysia. Bermula percuma, selamanya percuma. Apa khabar pelajar-pelajar? Harap semua berada dalam keadaan baik dan bersedia untuk meneruskan kelas kita pada hari ini. Cikgu percaya anda dah tak bersabar untuk meneruskan kelas kita hari ini. Untuk makluman semua, jadual baru bagi slot pre-U kimia dah tukar pada hari Ahad dari pukul 3.30 hingga 4.30 petang. Jadi, jangan lupa set kalender anda bersama dengan kita pada waktu ni. Link sijil penyertaan akan dipaparkan pada ruang bahagian komen sebelum kelas tamat. Kita bermula sesi hari ini dengan memperkenalkan cikgu-cikgu yang berada di pentas. Saya perkenalkan diri dahulu. Nama saya Cikgu Kong Shitli, selaku moderator pada hari ini. Saya adalah pensyarah kimia di Kolej Matrikulasi Perak. Saya yang berpengalaman selama 10 tahun. Bersama-sama dengan kita hari ini adalah Cikgu Vivi Lau, selaku control host. Sekarang mengajar di SMK Tengki Klang dan mempunyai pengalaman mengajar selama 19 tahun. Dan pemerhati Cikgu Tang mempunyai pengalaman mengajar subjek kimia selama 8 tahun. Sekarang perkhidmati Kolej Matrikulasi Selangor. Seterusnya ialah pembentang hari ini, Cikgu Shahnon. Sekarang kita bersiaran secara langsung dari channel Cikgu Shahnon. Bagi siapa yang belum subscribe, sila tekan butang subscribe sebagai tanda sokongan kepada Cikgu Shahnon. Beliau perkhidmati Kolej Matrikulasi Pulau Pinang dan berpengalaman mengajar subjek kimia selama 20 tahun. Hari ini, kita akan belajar kimia dengan tajuknya Introduction to Organic Chemistry, Reaction of Organic Compound. Kelas ini akan berlangsung lebih kurang 1 jam. Sebelum kita teruskan kelas kita, Cikgu Kong hendak ingatkan semua pelajar dan penonton yang ingin menghantar komen, sila menggunakan bahasa yang sopan dan gambar profil yang bersesuaian untuk tuntutan umum. Saya percaya semua yang hadir kelas pada hari ini merupakan pelajar-pelajar sopan dan cemerlang. Mari kita tunjukkan disiplin yang terbaik. Tanpa membuang masa lagi, jom mari kita belajar kimia bersama dengan Cikgu Shahnon. Dipersilakan Cikgu Shahnon.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Thank you Teacher Kong as a moderator, Teacher Lau as a control host, Teacher Tang as an observer. Hi student, hopes all of you are fine. So as usual, before we start our lesson, let me introduce myself. Okay. Wait a minute. Hang sekejap. Screen lagi sekali. Okay, let me share the screen. Okay. All right. Okay. Oh, tak bergerak.
Wait
Sekejap
for a while,
ya.
technical.
Technical problem. Wait a minute. Want to set it. Be okay. Okay, what about now? Still cannot lah.
While waiting, right, student, you can take out your lecture notes or reference book first.
Ya. Hey, okay. Tak
Wait,
apalah. Still cannot lah. I cannot share this. Okay. Dia buat macam ni lah. Dia ada problem. Okay. This is my my poster. Cannot show the this one. Still cannot. Okay. So, okay, this is my poster, and this is my profile. Can you see my profile? Okay, this is my profile. My name is Shahnon Benawi, and my institution is College Matrikulasi Pulau Pinang. My teaching experience 20 years, and I'm graduated from USN, Bachelor of Technology Polymer in 1996. Okay, my channel is Shahnon channel. All right, and this is our pre-made of pre-university mathematics. Okay, mathematics. Yes, this is mathematics, led by teacher Im, and we have teacher Eileen and also teacher Zainaria. And here is our poster, Kimia Prayu. Okay, this is me, teacher Tang, Cikgu Mawar, teacher Kong, teacher Lau, and teacher Yi. Okay, Yi. Okay. And this is a teammate of biology. This is teammate of physics. Physics, I think maybe next week we will have physics class. And then this is for accountant and economy. And here is a portal of Academy YouTube Malaysia. You can get many information from here, especially our schedule, of tuition online. Okay. All right. Let's go to our lesson today. Okay, I cannot. I don't know what happened to my computer, so I have to present like this. To make it, I think I can make it bigger. Can I make it bigger? How to make it bigger? Let me see what I can do with it. Okay, only this one. Okay. Okay, chapter 11 in matriculasi, we have chapter 7, Introduction to Organic Chemistry, 11.5, Reaction in Organic Compound. And our objective to explain covalent bond. So, okay, explain covalent bond cleavage, homolytic cleavage to produce free radical, electrolytic cleavage to produce carbocation and anion, and then state the relative stability of primary, secondary, and tertiary carbocation or carbonium. free radicals, and carbon ion. Explain the inductive effect of alkyl group towards the stability of carboxyl ion and carbon ion, and define electrophile and nucleophile. All right. First, we go to the covalent bond cleavage or covalent bond fission. All chemical reaction involve bond breaking and bond forming, right? Reaction occur at the active site, we call it functional group, and reactive intermediate occur in the course of reaction. The type of covalent bond cleavage, we have homolytic cleavage and heterolytic cleavage. All right, we go to the homolytic cleavage. Homolytic cleavage is a bond fission in which the bond shared electron of the covalent bond are split equally between the two atoms. Okay, we know that covalent bond has two electrons and then occur in a non-polar bond involving two atoms of similar electronegativity, and it will produce free radical. Free radical could be atom or group of atoms contain an unpaired valence electron. For example, here we have chlorine. Okay, this is chlorine, and the electron will split equally because this is covalent bond. We know that covalent bond has two electron here. One electron go to this chlorine, and another one go to the chlorine here, and it will have a Cl dot here. Dot here means unpaired valence electron. Okay, we have two chlorine atom that has one unpaired valence electron. So we say that this is free radical. Okay, free radical of chlorine. All right. And in this case, we will use arrow here. Can you see the arrow here? All right. Arrow here is a single-headed arrow. We call it single-headed arrow. Okay. And for the heterolytic cleavage, the bond breakage in which both electrons remain on one of the atom occur in a polar bond involving two atoms of different electronegativity. And it will form cation and anion. For example, we have carbon and bromine here. As we know that bromine is more electronegative than carbon, and when we have a bond breakage, two electron of a covalent bond here will go to the bromine, and then we will use double-headed arrow here, and we will have C plus here and Br minus. Okay, and C plus here we call it carbocation or carbonium. Okay, carbonium or carbocation. And if we have carbon, hydrocarbon, and we have atom here, and then the carbon here more electronegative than E here. Then when this bond break, two electron will goes to carbon. So the carbon will become C minus. We call it carbon ion. And we have E plus here. Okay. Okay. And here we have the we call it carbocation. Okay, CH3 plus and so on here. And here we have a free radical. And as I mentioned before, if we have carbocation, that means this this cleavage is heterolytic. Okay, for free radical, it's come from homolytic cleavage. Okay, and we have four types of carbocation. Number one, we call it methyl. This one actually is methyl carbocation, CH3 plus. Okay, it's actually come from CH4, and one of the H, the bond between H and carbon, it break equally, and no, this one is break the two electron goes to let's say carbon, let's say bromine. Okay, and we will have CH3 plus. Okay, CH3 plus, we call it methyl carbocation. This one we call it methyl free radical. Okay, and the second category we call it a primary. Okay, this one primary carbocation, because this carbocation C plus attached to one carbon. we write it as a R. R actually stand for alkyl. Okay, alkyl. This one, ALKYL, alkyl group. Okay. So this is secondary. This is primary carboxyl ion. This one is secondary carboxyl ion because this carboxyl ion attached to two alkyl group. And the last one is tertiary carboxyl ion because this C plus carboxyl ion attached to three alkyl group. The same thing goes to free radical. This is tertiary free radical. This is secondary, primary, and this is methyl free radical. All right. Now, if you look at this free radical and the carboxyl ion, the stability of carboxyl ion and free radical here increases with the number of alkyl group present. Okay. Here we have three alkyl group, and it's become tertiary carboxyl ion. And tertiary carboxyl ion more stable than secondary carboxyl ion, more stable than primary carboxyl ion, more stable than methyl carboxyl ion. Okay, why? Okay, this is the reason. The alkyl group are electron releasing. We call it electron releasing group, or we call it electron donating group. Okay, this help to stabilize the positive charge. As we can see here, this is a positive charge. And then because the alkyl group is electron releasing group, it will donate electron and it will stabilize the positive charge. All right. And the same thing goes to the free radical. It will stabilize the free radical of carbon here. Okay. And this is called inductive effect. All right. And relative stability for carbon ion, we have a opposite, okay, opposite effect. Okay, in this case, the methyl carbon ion, carbon ion, more stable than primary carbon ion, secondary and tertiary. Okay, of course, because the what we call it. This is because the alkyl group will decrease the stability of carbon ion. Okay, carbon ion, actually the carbon here, it has a lot of charge. So when the alkyl group here try to donate electron, so it try to what we call refuse it, maybe something like that. So the tertiary carbon ion less stable compared to the secondaries, primary and methyl. Okay. And then, okay, reagent and site of organic reaction. In organic compound, we have what we call organic compound, and organic compound will react with reagent. All right, it will reagent and to form intermediate, and the last one is the product. Now we go to the reagent and also the site of organic reaction. Okay, we have a definition of electrophile. Number one is electrophile. What is electrophile? Electrophile means actually is electron lover. Okay, electrophile is electron lover. Okay, the exact definition is an electron deficient species which is capable of accepting electron pairs. It attacks electron-rich area of organic molecule and can be either neutral or positively charged. Okay. All right. The problem is I cannot write something here. Okay, I try to try again. If okay, can everyone see the? Because from my point of view, I can see the still cannot. Okay, let's see. I present it from. Okay, try again. Present it from. Let's see. Okay, teacher Lau, I try to present it again. Hopefully this one share screen, but this one I try entire screen. Is it okay? I try application window, but it's not working. But I try entire. Is it okay? Try to entire. I don't know, but I try. Entire share. Oh, cannot. I cannot share entire window. Okay, I can try share window. Can you see my? All right.
Okay, okay rồi.
Okay, all right. Okay. So I have to share my entire window. Okay, electrophile. Okay, electrophile is an electron deficient species which is capable of accepting electron pair. All right. It attack electron rich area. Okay. What is electron deficient species? Okay, electron. How to say that? Species that lack of electron. Okay. So usually the now I can use my all right. Usually we use E plus here. Okay, E plus. E stand for electrophile, and we have a plus sign here, so easy for us to remember, right? E plus, it will attack electron-rich area of organic molecule. Okay, it can be either neutral or positively charged. Okay, as I said before, so to easy for us to remember the electrophile, as I said before, E plus. So whatever the species that has a positive charge, we can say there is electrophile. Okay, NO2 plus, H3O plus, C plus. This is carbocation. This is carbocation or carbon ion. And also site of low density. For example, C double bond O. The C here is partially positive. Okay, partially positive. The positive charge, we can relate it to the electrophile. And the second one is for neutral is electron deficient species. For example, is AlCl3, PF3. As we know that this is AlCl3 is in a Lewis structure. We already know that this is what we call incomplete octet, right? Incomplete octet. The aluminum here not enough electron. One to only 6 electron. Okay. For the incomplete octet, yes, it is. This is electron deficient species, and it is electrophile. All right. And for oxidizing agent, bromine and chlorine, maybe we don't know whether this is electrophile or nucleophile, but we can make it clear when we see the reaction. Okay, this is electrophile, and okay, nucleophile. Okay, good. Nucleophile. What is nucleophile? It's an electron-rich species which is capable of donating electron pairs. Usually we will use this nucleophile is Nu. Okay, and it has a negative here, and also the 2 dot here. The 2 dot here. Easy for us to remember this one for the nucleophile. Whatever the species that has a negative sign, we can relate it to the nucleophile, and also the lone pair. Okay, can be either neutral or negatively charged. Okay, for example, okay, we have OH minus, okay, negative charge here, RO minus, Cl minus, Cn minus, carbon ion, C minus, okay, carbon ion. And also ammonia. Ammonia, as we know that ammonia has one lone pair, and at nitrogen atom, okay, or Lewis base, okay, whatever Lewis base or species or compound that has a lone pair here, okay, because when it has a lone pair, it can donate a lone pair, okay. Okay, H2O and also H2S. Okay, this is a nucleophile, as I said, nucleophile, lone pair, and also a negative charge. And then site of high electron density, carbon-carbon double bond, carbon-carbon triple bond, and also benzene ring. Okay, this is site of high electron density, so easy for them to donate a pair of electron. Okay, all right, that is electrophile and nucleophile. Okay, we have a question here. The bond dissociation energy for homolytic cleavage are as below. We have a CH3H, actually this is CH4, and this is bond dissociation energy in kilojoule per mole, 435. And we have CH3, CH2, H. Okay. That's mean what we have to do is we want to break this bond, and the electron is given to the carbon and hydrogen equally. Okay, like this. Okay. The question number one is, what is the homolytic cleavage? Okay, this is homolytic cleavage lah. A bond fission in which the two shared electron of the covalent bond are split equally between the two atoms. Okay, and then you have to write the free radical that are formed due to the homolytic cleavage. Okay, due to the homolytic cleavage, and rank them, increasing order of stability. All right. In this case, actually, we can write the free radical of CH3, and when we just put oops, not yet. Okay, we can put one dot to the carbon here. Okay, it will become free radical of carbon. Okay, but how to rank them? Okay, we can use this bond energy. Okay, the higher the bond energy means not easy for the compound to form free radical. Okay, the higher the energy, not easy to the compound to form free radical. That means less stable. That means less stable. In this case, we have to rank them increasing order of stability. Okay, from this value, we know that this one is the most least stable. Okay, 435. And then followed by this is number one, right? This is the least stable, followed by this one, and then 397. Okay, this is number 3, this is number 4, and this is number 5, right? We have to rank them, and then you have to write the free radical. Okay, so the answer is like this: CH3 dot followed by CH3, CH2 dot. Okay, this one. And then CH2, CH dot. This one. 397. And then CH33, this one. Okay. As we can see here, actually this is tertiary carbocation. No, this is tertiary free radical, like this. This is tertiary free radical. We know that the tertiary free radical is more stable than this one is secondary. Okay, this is secondary, like this. This is primary, and this is methyl free radical. And this one is actually, this is it has a benzene ring here, and then CH dot here. And this one we will discuss later. Why this one, which has a benzene ring, more stable than the tertiary free radical, right? Okay. And then the second exercise. The second exercise, classify the following species as free radical: carbocation, carbanion, electrophile, or nucleophile. If you have any question, you can write in the chat box. Classify the following species as free radical: carbonium, carbanion, electrophile, or nucleophile. Okay, this one. What is this one? CH3 in bracket 2 CH minus. Actually, this minus is for carbon. Okay, number one. Anyone can answer this question? Number one, CH3, 2 CH, and then we have a minus sign here. What is this? Is it free radical? Is it carbonium, carbanion, electrophile, or nucleophile? Remember that, okay, if we have carbon that has a minus sign or carbon that positive sign, we just say this is carbocation or carbonium. Okay.
Hi,
For
hi Cikgu Shahnon.
yeah.
Let's
Any
rest
question?
for a while first and then give some time for students to answer. Okay, yeah.
Okay. Right.
Hmm.
Any question? I just want to clarify that.
For the time being, time being, no
Okay.
question.
Yeah. No question. Right. C minus here, as we can see here, as I said before, for the nucleophile, okay, we can say that C minus is nucleophile. But in case of organic compound, if we see the C minus, automatically we say this is carbon ion. Okay, and the
Okay.
same thing goes to the electrophile. Electrophile, we know that whatever species that has a positive charge here, and when it goes to the C plus here, we know that this is electrophile. Yes, this is electrophile, but
Hi,
we
Cikgu Shahnon.
automatically yes.
We stop for a while first and go for advertisement.
Oh,
Okay.
half an hour already. Okay.
Okay.
Alah, apa ni? PKPB lagi. SPM pula ditangguhkan. Jenuhlah nak bayar yuran tuition. Pernah dengar tentang tuition percuma? Kami di Akademi YouTuber menyediakan tuition online secara percuma kepada anda semua. Ada prasekolah, sekolah rendah, sekolah menengah, SDPM juga untuk matrikulasi. Percuma je. Jom layari laman sesawang www.academyyoutuber.com.
Okay, mari kita sambung semula.
Okay, welcome back. Okay, alright. As I said that if we have a C plus here, automatically we can say that this is carbocation. Carbocation, carbonium. Okay. C minus, carbon ion. Okay, what is this? CH3 in bracket C, and then we have CH and minus here. So any answer from student? What is this? This is the clue, the minus sign. Any question, any answer?
For the time being, no answer yet. Okay.
No. Okay. This is a very easy question. Okay, we have a dot here. What is, if we have a dot, what is dot? Only one. Dot is free radical. Okay, free radical. Okay, I still okay. What is that? All right. Here we have a C plus here. C plus. What is C plus? C plus. C plus is carbocation or carbonium or carbocation. Okay. Now I settle for carbon. Carbon, it could be carbocation, it could be free radical, it could be carbon ion. This one is carbon ion. Carbon ion. And this one,
Yes,
CH3O
Cikgu Shahnon.
minus. Yeah. Yeah.
Anis Zahira answered carbo and ion. Correct.
Okay, good. Correct. This one. Okay. Okay, for this one, CH3O minus. Now, the minus is belong to the oxygen here. So this is not carbon ion. Okay. This one, remember that. Remember that if we have a minus, remember this one, Nu minus and 2 dot. Okay. Nu stand for nucleophile. Okay. So this one is nucleophile. And this one, NO2 plus stand E plus. Remember E plus? E plus is electrophile, all right? Okay, settle. And then, okay, B, ethane react with bromine according to the equation, CH3, CH3 by bromine, CH3, CH2, Br, and so on. Write the structure formula of the organic species form when CH3, CH3 undergoes homolytic fission. Okay, remember CH3 and CH3 undergo homolytic fission. Okay, how to write the structure formula of the organic species? Okay, organic species. Organic species mean carbon and it has a hydrogen. Okay, that's mean this one CH3 CH something like this. Okay, it will split equally something like this. Okay, the answer is CH3 CH2 dot. This is organic species. Huh? H dot here is not organic species, so no need for us to write the H dot. We just write the CH3 CH2 dot because according to this equation, organic species. All right, the answer is H3 CH3 CH2 dot. Okay, for the second question, write the structural formula of. Okay, this one is formula of the species form when blah 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 undergo heterolytic species. Okay, for this one, let me. Okay, in this case, heterolytic fission. Heterolytic fission, we will have the product of positive and negative cation and anion. So the CH3, CH2, Br, this one, the heterolytic cleavage or heterolytic fission, the 2 electron goes to bromine, right? So the answer is CH3, CH2 plus Br minus. Okay, so the answer is this one. CH3, CH2 plus and Br minus. I think I should change my, where is it? This one, highlighter. Okay. All right. Now we go to the a lot of exercise, but I think I'm running out of time, so we go to the main type of organic reaction. We have electrophilic and nucleophilic addition, electrophilic, nucleophilic substitution, elimination, and rearrangement. Okay. Type of organic reaction, we have 4 main types: addition, substitution, elimination, and rearrangement. Okay, basically we have 4, but this one we can have a pecahan lagi lah, ada lagi. Okay, we go to the addition reaction. A reaction in which atom or group add to adjacent atom of a multiple bond. 2 types of addition. We have electrophilic addition, okay, initiated by an electrophile which attack a nucleophilic site of a molecule. Typical reaction of unsaturated compounds such as alkene. This is very typical for electrophilic addition. Unsaturated compound. What is unsaturated compound? Compound that has multiple bond. Alkene, alkyne, benzene, and so on. That is what we call unsaturated compound. Okay. Saturated compound, for example, alkene, only single bond. Okay. Okay, this is example. Okay, electrophilic addition, alkene or alkyne, benzene, and so on. Okay, we have a double bond here, and then as we can see here, it react with bromine. Bromine, we call it reagent. This is reagent. This is organic compound. Okay, at room temperature, what happened? What happened? The bromine here, the reagent, is add to the organic compound. So it's become like this. That's why we call it addition. Bromine is added to the organic compound, right? And from unsaturated compound, now it's become saturated compound. Okay, can you see? From unsaturated, double bond, triple bond, and so on, and the product is all is single bond. So this is addition. Okay. Why the name is electrophile? Okay. First, we see bromine here. We don't know. Actually, the bromine here is electrophile. How do we know the bromine is electrophile? Okay. We don't know, right? We don't know. Yeah, I also don't know. But I know that the alkene here is nucleophile. Okay. Alkyl is nucleophile. How do I know this is nucleophile? Because double bond is electron-rich species. Okay? Triple bond, electron-rich species. That means in a reaction of organic compound, nucleophile must react with electrophile. Okay, nucleophile cannot react with nucleophile. Nucleophile will react with nucleophile. So I know that alkene is nucleophile. That means bromine here must be electrophile. So the name actually this one we call it type of reaction. Type of reaction. The type of reaction come from the reagent and also the organic compound. Electrophile from here, addition add to the organic compound. So electrophilic addition. Okay, electrophilic addition. Is it okay? All right. So we go to the nucleophilic addition. For nucleophilic addition, initiated by a nucleophile which attack an electrophilic site of a molecule, typical reaction of carbonyl compound. Okay, we have a carbonyl compound. Okay, here we have also the unsaturated compound, C double bond O. Okay, we have a double bond, and the product only single bond. Okay, if we have a double bond and the product is single bond, this is must be addition reaction. Okay, we know that C double bond O, this carbon here is partially positive. Partially positive is electrophile. If this is electrophile, this one must be nucleophile. Okay, actually this HCN we will have a CN minus. Okay, CN minus. Okay, we have it. Nucleophile. Nucleophile here will add to the carbon here, and then okay, it's become like this. That's why the name come from nucleophilic from reagent and addition. We add to the organic compound. So nucleophilic addition. Okay. In addition, we have two types: electrophilic and nucleophilic addition. Okay. Substitution reaction. A reaction in which an atom or group in a molecule is replaced by another atom. Is replaced by another atom or group. Okay, group of atom. Three types. This one we have a lot of compared to the addition. Okay, number one is free radical substitution. Okay, this one actually is homolytic cleavage. Okay, this is homolytic cleavage, as what we learned before. Okay, for example, we have an alkane here. This is alkane CH3 CH3. Okay, CH3, and we have a chlorine in the presence of UV light. What happens is the H here is replaced by chlorine. Okay, can you see the replacement of hydrogen and chlorine? We call it substitution. Okay, the chlorine will substitute hydrogen. All right, and this is saturated compound. Okay, the product also saturated compound, and for alkene, actually the reaction of alkene is a free radical substitution, and we have a UV light here. This is all the clue lah. Okay, the clue. Sometimes we clueless. We no clue, but actually the UV light is the clue that this is free radical substitution. And the thing is, alkane. The reaction of alkane only free radical substitution. Okay, and also maybe combustion. Okay, combustion and free radical substitution. Okay. The second one is electrophilic substitution. Okay, you can see the name is electrophilic substitution. Typical reaction of aromatic compound. Okay. aromatic compound. Actually, the name should be electrophilic aromatic. Electrophilic aromatic substitution. The aromatic nucleus has high electron density, thus is nucleophilic and is prone to electrophilic attack. Okay, this one. We already know that this is a nucleophile. Okay, benzene. Oh, I can draw like this. Okay, like this. Benzene has a single bond and double bond alternate. The single bond and double bond alternate. Or we can write like this. We have a circle inside here. Okay, this is nucleophile. As I said, if this is nucleophile, this one bromine must be electrophile. See, so the electrophilic, and the H here is replaced by bromine. So the name is electrophilic aromatic substitution. Okay. All right. This is electrophilic aromatic substitution. And the third one in substitution reaction is nucleophilic substitution. Okay. See here, this is nucleophilic. So we should have a nucleophile as a reagent. Okay. And replace wherever in aromatic compound, organic compound here. We have CH3, CH2, Br, and then we know that bromine is more electronegative than carbon. So the carbon here should be partially positive with electrophile. And here we have OH minus. We already know that OH minus is a nucleophile, yeah, nucleophile, Nu minus, and double dot here, and nucleophile, and then the bromine is replaced by OH. So this is nucleophilic substitution. Okay, single bond. The reaction, the reactant is all single bond, and the product also all a single bond. So this is not addition. Okay, this is substitution. Okay, Br is replaced by hydroxyl OH. Okay, and then we have elimination. This one quite easy. A reaction in which atom or group are removed from adjacent carbon atom to form multiple bond. Okay, from single bond to double bond, or from single bond to triple bond, or from something like that. So elimination reaction result in the formation of unsaturated molecule. Okay, so example is CH3 CH2OH, alcohol, concentrated H2SO4, and then we heat usually 180 degrees Celsius, and we will have alkene here, CH2 double bond CH2. Okay, from saturated to unsaturated. Okay, this is elimination. Elimination, bukannya Eli Mazlin. This is elimination, not Eli Iskandar. Okay, this is elimination. Okay, the last one is rearrangement reaction. A reaction in which atom or group in a molecule change position to form a more stable structure. For example, we have enol. Double bond is alkene, and then we have OH alcohol. That's why the name is enol. Okay, in alkene and alcohol, enol. Okay, enol. This is actually not stable for enol, because this carbon has two functional group, double bond and OH hydroxyl group. So not stable. It will arrange itself. The H here go to here, and double bond go to here. So it's become keto. We call it keto. Actually, this is aldehyde. Aldehyde. So this one we call it keto enol tautomerism, and we can see that this is actually rearrangement. Okay, we rearrange the hydrogen goes to here, and double bond goes to here. So this is rearrangement reaction. All right, settle. Okay, and then we have also alkene here. Okay, as we can see, alkene here at carbon number 1, the position of carbon number 1 at carbon number 1 and number 2. Okay, and then what happened? It rearranged itself. Now the double bond, carbon double bond here at carbon number 2 and number 3. Okay, carbon number 2 and number 3. So this is double bond rearrangement. This is always happen in organic compound. Okay, we go to our exercise. How many minutes we have? How many minutes? Okay, we have 10 minutes. Okay, good.
10 minutes.
Okay, 10 minutes. Okay, identify. Okay, student, now identify the type of reaction shown by the following equation. Okay, you can type your answer. We have a alkene here. Okay, double bond. Okay, double bond. This molecule, we call it unsaturated. And then the product is saturated. Okay, what is type of reaction? Okay, we call it type of reaction. Type of reaction. Name for this reaction is bromination of alkene. Okay, but the type of reaction is what? Okay, what is the type of reaction? Okay, you can answer. Okay, any answer? We have a lot of time now. 10 minutes. I have a lot of exercise. Okay, anyone?
No answer yet.
Anyone?
Let's.
No answer yet. Okay. Okay, student. Easy. This
Okay.
one.
Yeah.
Okay.
Nur Hidayati.
Okay.
Electrophilic
Example.
addition.
Electrophilic addition. Okay. Anyone? Electrophilic addition. Rest. Okay. Electrophilic addition. Yes. The answer is electrophilic addition. Good.
Lim Shooting, correct. Electrophilic addition.
Electrophilic addition. Huh? Because this is double bond, and now it's become single bond. So this must be addition. Okay. We don't know the bromine. Okay. Not easy to characterize the bromine. Okay. So we look at alkene. Alkene is electron-rich species. Okay, electron-rich species is nucleophile. Okay, nucleophile. So bromine is electrophile. So electrophilic addition. Okay, the second one. The second one from alcohol. Alcohol, and then we have acid, and then we heat. It's become alkene and H2O. What's the answer? Alcohol is um, saturated. Okay, saturated compound. Okay. Okay, answer. And now we have alkene and H2O from 1 to 2. This one from 2 to 1. Okay? We have
Answer from Hidayati again.
okay,
Elimination.
elimination. Okay, not elimaslin. Elimaslin or elimination?
Elimination.
Okay, elimination. Okay, good. Elimination. Elimination reaction. Okay, good. Number 3. Number 3 is also alcohol. Okay, alcohol, ethanol here. HCl and zinc. We call it Lucas. Okay, you will learn it after this. And now we have chloroethane. Okay. Okay. Any question? Any question? Any answer from the student?
Okay. Or C, not yet.
See, not yet. Okay, look at here. This is OH. This is Cl. Okay. Don't look here. No, you don't have to look here. Just look at the organic compound. Organic compound. What happened to the organic compound? And then we can determine the type of reaction. Okay, just look at the organic compound. Organic compound. Okay, anyone? CH3, CH2OH. Now it's become CH3, CH2Cl. CH2Cl. So is it this is addition or elimination or substitution or rearrangement? Which one? Okay, that is the first thing that you have to determine. OH and Cl. So this is what? Any answer? Not yet. Aduh. right? OH,
Okay,
HCl.
from Ernie. Ernie Wanli,
Ernie.
substitution.
Okay. Substitution. Good. Substitution. What kind of substitution? Because substitution we have three type of substitution. Is it free radical substitution? Is it nucleophilic substitution or nucleophilic substitution? Which one?
Ernie, try again.
Okay.
Annie's substitution as well.
Okay. What type of substitution? We know that OH is replaced by Cl, right? The Cl is what? Cl minus or Cl plus or Cl dot, which is replace the OH.
Ernie and Annie's try to answer again. What type of substitution?
What type of substitution? OH, usually OH is what? Okay, from your previous knowledge, the OH comes in what form? Is it OH plus, OH dot, or OH minus? So this is the clue. Okay, OH.
Okay, Annie's nucleophilic. Give the answer nucleophilic.
Nucleophilic substitution. All right, good. Yeah, because usually OH is OH minus, and to replace OH, of course, must be Cl minus. Okay, in substitution, usually when the OH minus, we remove OH and we have to replace it with something that also has a negative charge. Okay? And we know that Cl minus is nucleophile. Remember, Nu minus and double dot. Okay, if we can see that, oh, it has a double dot. Okay, that's nucleophile. Okay. All right. Okay, the number four. CH3 is, and then we have here. This is the clue here. Okay, we have a reversible sign, and usually the reversible sign is not the long is not the same. Okay, if we have the reversible sign, usually it's referred to what? Okay, number four.
Rearrangement from Hanis
Yeah.
Myra.
Okay, good. Rearrangement. Actually, this is tautomerism lah. This is tautomerism. Double bond keto enol. This is enol lah. E double bond NOH enol. Bukan enol lah.
Yes.
Enol is dangdut. This is enol. And this is ketone. It's becoming keto enol tautomerism. Okay. Number 5. Okay, number 5. We have C6H6. What is C6H6? You have to know the C6H6 actually. What is C6H6? This is Ben what? Ben No, this is benzene. This is benzene. C6H6. We have a benzene, and then the product. Okay, remember, always look at the organic compound. Okay, sometimes we just have to look at the organic compound, and then we know what happened. This is C6H6. Now it's become C6H5. Oh wow! One of the H is replaced. One of the H is replaced by CH3. Can you see? Can you see? C6H6, and then when it react with CH3Cl in the presence of Cl3, it's become C6H5. What happened to the one of the H? That means one of the H from C6H6 is replaced by CH3. So, what type of this reaction?
Hanis Myra answer number 5 is substitution, free radical substitution.
Free radical substitution. Okay, the free radical is correct, but the free radical. Okay, try again.
Hanis, try again.
Okay, this one is quite okay because you don't know what is CCAC, right? Okay, the CCAC is this one. Benzene. You still don't know the benzene. The benzene is aromatic compound. Okay, aromatic. Now we have a term aromatic. So the answer should be what? Okay. Benzene is, as I said before, benzene is a nucleophile. Okay, because in benzene it has a double bond, single bond, and single bond. So benzene
Okay.
is electron-rich species.
So
Okay, the answer?
answer from Nu Hidayati,
Mhm.
electrophilic aromatic substitution.
Electrophilic aromatic substitution. Yes, correct. Electrophilic aromatic substitution. Because this is a nucleophile, so this one will be electrophile. How it become electrophile? You will learn it in the next chapter in benzene. Don't worry. But for this chapter, we just want to know the type of reaction. Okay, how many minutes we have? Actually, I have a lot of questions. Oh, okay. Out of time already. Yeah? Okay. So
Yeah.
thank you. Please
Okay,
subscribe, like,
terima
and share.
kasih. Okay. Terima
Okay,
kasih kepada
sekian.
Cikgu Shahnon.
Okay.
Akhirnya dah selesai kelas kita pada petang ini. Tahniah diucapkan kepada semua yang sedia bersama kelas pada petang ni dari awal sehingga ke saat ni. Sebelum kita tamatkan sesi siaran langsung hari ini, mohon semua sila klik butang subscribe dan aktifkan ikon loceng supaya kamu tidak terlepas sesi kelas yang seterusnya. Sekiranya kamu suka dengan apa yang dipelajari hari ini, sila klik like dan share kepada rakan-rakan di media sosial anda untuk sebarkan ilmu dan peroleh kebaikan di atas perkongsian tersebut. Link CJ akan diberi sebagai tanda terima kasih kepada anda menyertai kelas tuition percuma hari ini. Okay, sekian, terima kasih.
Tuition online percuma. Tuition online percuma. Layari www.academyyoutuber bagi mengikuti tuition online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuition online percuma mestilah Akademi YouTuber.
Dibawakan kepada anda oleh Akademi YouTuber.